Okay, so this is the key to 2.1 part 2, and on the first page, you're just evaluating functions either at a numerical um, value for x or at a variable expression. All right, so now there was no work to show here. You just had to put in the answers, but obviously there was something you had to do. So I'm going to do the work on another sheet of paper just to show you what to do. All right, um, so number one, my function. Now remember, f of x means the same thing as y. So this is really the same thing as saying y equals 3x squared minus 3x plus 1. So that's just function notation. Same thing for g of x, h of x, k of x, just function notation. So that h of x, that g of x, that f of x means the same thing as the y variable. Okay, now, so number one, you have f of x is 3x squared minus 3x plus 4. And you want to find, in letter A, you want to find f of negative 2. All right, so now remember that does not mean f times negative 2. So don't go ahead and multiply all this by negative 2. That's not what that means. That means f of negative 2, remember we say this f of negative 2, f of negative 2 means what's the y value, what is the y value when x equal negative 2. Okay, so in place of x, where we see the variable x, you're going to plug in negative 2. So if you have to underline the variable x in the function and then draw arrows to it, then go ahead and do so. All right, so then we get 3 times negative 2. Notice I'm putting x in parentheses, squared, don't forget that's being squared, minus 3 times x in parentheses, negative 2, plus 4. So 3x squared minus 3x plus 4. So x is, in each case, x is negative 2. All right, using the order of operations, I'm going to do exponents first. Negative 2 squared is 4. 3 times 4, this is 3 times 4, is 12. Okay, negative 3 times a negative 2 is a positive 6, and then plus 4. So I get 12 plus 6, which is 18. 18 plus 4 is 22. All right, so in the blank, you would say f of negative 2 equals 22. So in this blank, you would say 22. Right here, you'd say 22. Now just keep in mind what that means. So if you were to graph this, and you will soon, but if you were to graph this, what this means is that when x is negative 2, y is 22. So the ordered pair would be negative 2, 22. All right, but that's not necessary in this worksheet, but that's what this means. You'll see this later. Okay, now letter B, you want to find f of negative x. So again, f of x is 3x squared minus 3x plus 4, and you want to find in B, you want to find f of negative x. So again, where we see the variable x, just like we did here, where we see the variable x, you're going to substitute negative x. All right, so I'm going to get 3 times, and remember when I substitute negative 2 here, I put all that in parentheses. So 3 times negative x squared, because I'm squaring, minus 3 times, right here, minus 3 times x. So in place of x, I'm going to substitute negative x, and then plus 4. All right, now let's look at this right here, this negative x squared. So remember, negative x squared means negative x times a negative x. That's what that means. Well, negative times a negative is a positive, and x times x is x squared. So this right here becomes 3x squared. Now, negative 3 times a negative x is a positive 3x, and then plus 4. So f of negative x is equal to 3x squared plus 3x plus 4. So that's what you put in the blank. So you'd say f of negative x is, let's see here, you'd say 3x squared plus 3x plus 4. All right, so just keep in mind that, see how I substituted a negative 2 for x? So that's a real number. I end up with a real number. Here I substitute a variable expression for x. I'm going to end up with a variable expression. All right, so just keep that in mind. All right, number 2, you have this function now. And so number 2, you have f of x is f of x is the square root of 4x minus 4 plus 2. And so you want to find, in part A, you want to find f of 5. So again, where we see the variable x in your function, you're going to substitute 5. So I see it here. So I get the square root of 4, don't forget to put it in parentheses, 5, that's a 5. 4 times 5 minus 4, and then plus 2. Alright, so 4 times 5, I'm substituting 5 into x, so that's what you see here, minus this 4, so that's this part here, and then plus 2. Okay, using the order of operation, we simplify the radicand. So 4 times 5 is 20. So I get 20 minus 4 plus 2, which is the square root of 16 plus 2, which is, and the square root of 16 is 4, and 4 plus 2 is 6. So f of 5 is just 6. So that's what you put here. So f of 5 is 6. Okay, now in part B, I can go ahead and do that here. So remember, f of x again is this. F of x is the square root of 4x minus 4 plus 2. And in part B, you want to find f of 2x plus 1. So again, where we see the variable x, you're going to plug in, you're going to substitute 2x plus 1. That's what you're going to do. Now, remember how when we substitute, we put them in parentheses. We put them all in parentheses. Notice I put everything, whenever I did a substitution, I put it in parentheses. I put a parentheses and put that in. Same thing here. So it'll be the square root of 4 in parentheses 2x plus 1. Make sure you put parentheses, because if you don't, you're going to miss this, because you have to distribute here. Then minus 4, and then plus 2. Now distributing, I get the square root of 4 times 2, 8 is 8x. 4 times 1 is 4, that's plus 4. Plus 4, and don't forget the minus 4, and then plus 2. And so I get the square root of 4 and a negative 4 is 0, so I just get 8x plus 2, and then there's nothing else you can do here. I mean, you can simplify the square root of 8, but it's not going to help you. So there's your answer, the square root of 8x plus 2. 8x plus 2. Okay? All right. Number 3. Okay, so number 3, you have this now. Number 3, you have this function. You have f of x. Oops, it says g of x. So you have g of x equals the absolute value of 2x minus 1 divided by x plus 4. Alright, so you want to find g of negative 2. G of negative 2. So again, where we see the variable x, and I see it twice here, you're going to substitute negative 2. That's all you're doing. So, but don't forget though, that's absolute value, so be careful. Remember what that means. So I'm going to get the absolute value of 2 times negative 2 minus 1. So notice all I did was just rewrite, in place of x, I substitute negative 2. Don't forget, you see how the absolute value, don't throw that away. That's going to be important. Over, and then here's the other x, so you can say negative 2 plus 4. And again, if you didn't have to put parentheses here, because there's nothing else attached to that term right here. But you could have if you wanted to. So that's going to be the absolute value of 2 times negative 2 is a negative 4 minus 1. That's what we have in the numerator. Make sure you see that. So this one is easy to mess up if you're not careful. And then negative 2 plus 4 is just 2 in the denominator. Now in the numerator, let's go back to the numerator. Simplify that. Negative 4 to negative 1 is a negative 5. Absolute value. Don't forget the absolute value over 2. And then the absolute value of negative 5 is 5 over 2. So the answer is positive 5 halves. So that's g of negative 2. So g of negative 2 is 5 divided by 2. Okay, now part B, you're substituting a variable expression now. So let me go ahead and just rewrite the function again. Alright, so when you write the function, I'm finding g of x plus 4. So wherever you see the variable x, I'm going to substitute and plug in x plus 4. Okay, so I'm going to get absolute value of 2 times, in parentheses, x plus 4. Look at how it looks. In place of x, you can plug in x plus 4. 2x, so 2x plus 4. 2 times x plus 4. And then minus 1, absolute value, divided by, this is x, so that becomes x plus 4. and then plus 4. So the numerator, this is a little bit more challenging, so you got to be careful. So the numerator, you're going to distribute now, so that becomes absolute value of 2x plus 8 minus 1 over, and then 4 plus 4 is, so this right here, just notice, that's x plus 4 plus 4, so it's x plus 8. And so, combining like terms here, that's going to be a 7. 8 minus 1 is 7. I get the absolute value of 2x plus 7 divided by x plus 8. Now, there's nothing else you can do here. You can't just get rid of the absolute value bar because you don't know if x is negative, then this numerator would have to be positive because you're taking the absolute value. So you can't just get rid of it. If you get rid of it, then that means that this numerator can, if you plug in a negative number for x, let's say, and let's say you're graphing this, then you would get a negative number, and that's not what this says. You want this numerator to be positive. So leave it alone. You can't do anything else to it. You may say, well, you got rid of it in the previous one. Yeah, but that's because that was a number. You know what the absolute value of negative 5 is. The absolute value of negative 5 is 5. That's a numerical expression. All right, so you know what that is. You can tell me right away what that equals. Absolute value of negative 5 is 5. Here you can't because you don't know what x is. X could be positive, x could be negative, x could be 0. But whatever that is, you have to take the absolute value of it. All right, so if it's a variable expression, leave the absolute value bar there. Don't get rid of it. So the answer number 3b would be this. It would be absolute value of 2x plus 7 divided by x plus 8. So that one was challenging. Okay, 4. Your function is k of x is equal to 5x plus 4. And so in part A, you want to find k of 3. So again, wherever we see the variable x, you're going to plug in 3. So I get k of 3 would be 5 times 3 plus 4. So that's 15 plus 4, which is 19. So that's k of 3. So k of 3 is equal to 19. Part B, k of negative 4. So remember, this is k of x. All right, so part B, you want to find k of negative 4. So in place of x, you're going to substitute negative 4 this time. So I'm going to get 5 times negative 4 plus 4. So that's negative 20. 5 times negative 4 is negative 20 plus 4, which is negative 16. So k of negative 4 is negative 16. So that means that when x is negative 4, your y value is negative 16. So say negative 16. Part C, remember k of x is this. So k of x is 5x plus 4. So in part C, you want to find k of negative x. So again, where we see the variable x, you're going to substitute negative x. So that's what that says. So I get 5 times negative x plus 4. So 5 times negative x is a negative 5x plus 4, and then you're done. You can't combine them. They're different terms. They're not like terms. So that's your answer there. So k of negative x. Remember, when you substitute an algebraic expression, you're going to get an algebraic expression for your answer. So that's negative 5x plus 4. And then D, so remember k of x is this. So D, you want to find k of 2x minus 1. So again, where we see the variable x, you're going to substitute 2x minus 1. So I get 5 times 2x minus 1 in parentheses. 5 times 2x minus 1, and then plus 4. Distribute. I get 10x minus 5 times negative 1 is a negative 5, plus 4. Combine like terms. I get 10x. A negative 5 and a positive 4 is a negative 1. So there's your answer for D of 2x minus 1. So D of 2x minus 1 is 10x minus 1. Okay? All right, so now let's look at the next one. So in the next one, okay, so this time you're given a graph of a function, and you want to find each of these. So you want to find f of negative 4. So remember what we talked about earlier when we did this. If I can find it, we said that f of negative 22, when we said that equals 22, that means that when x is negative 2, that's what your y value is. So your y value is 22. All right, so in order of pair, that's what it would be, negative 2, comma 22. X is negative 2, y is 22. So when you look at this one, Look at this one. Same thing. So the question is, when x is negative 4, what's the y value? So that's what you're asking. When x equals negative 4, y equals what? Okay? So what you need to do is look at the point of the graph where x is negative 4. Well, remember, x is negative 4. Here's the x-axis where x is negative 4 right here. There's the point of the graph. So you got to denote that point of the graph. So that point here, if you label it, is negative 4 comma negative 2. That's what that is. So it helps if you label these points. So negative 4, 2. So that means when x is negative 4, my y value is negative 2. All right, here that says when x is 1, so you already have a dot there. When x is 1, that coordinate is 1 comma 1. So 1 comma 1. So that means your y value is 1. When x is 2, that's this right here. When x is 2, label that point. That's going to be 2 comma, and then that y value is, so notice when x is 2, here's the point of the graph, that y value is 4. All right, so you need to be able to do things like this. When x is 0, remember this is where x is 0, so there's the point of the graph, that y value is 1. That y value is 1. In fact, all of this, no matter where you are, between negative 1 and 1, your y values are 1. Okay? Alright, so now you want to list the x-intercept as an ordered pair. There's only one x-intercept. This graph crosses the x-axis only one place. That's here. So as an ordered pair, remember though, that's negative 2 comma 0. So don't just say negative 2. It says list as an ordered pair, so you must list as an ordered pair. And so remember, that's negative 2, 0. Remember, it's not 0, negative 2. 0, negative 2 is on the y-axis. Alright, so you got to be careful. Alright, then state the y-intercept as an ordered pair. So the y-intercept, that's where the graph crosses the y-axis. Well, that point is 0, 1. 0, 1. Alright, then it says, for what values of x is f of x equal to negative 1? So remember, f of x means the same thing as y. So the question is, where is y equal to negative 1? Well, on the graph, locate negative 1 on the y-axis. So here's negative 1 on the y-axis. Go to the point that's on the graph. So that's the point that's on the graph here, right here. Okay? And then label it so that when I label that point, that's negative 3 comma negative 1. And so now you're asked this. So when y is negative 1, so here's y, you said y is negative 1, so here's y negative 1, what's that x value? So the x value is negative 3. Same thing with that one. Find the value of x when y, remember this is y, equals 4. So y equals 4, okay, that's not going to be a good one. Okay. So, right here, I'm sorry. When y is 4, excuse me. When y is 4, that's where y is 4. So this point here, remember, it's 2, 4. So when y is 4, my x coordinate is 2. So x coordinate is 2. Okay? Alright, so that takes care of the worksheet on section 2.1, part 2.